So for this problem, we're going to be rotating around the y-axis. And if we're going to make a disk and you rotate around the y, that means your rectangle has to be perpendicular to the y-axis. So whichever axes we're rotating around, if we're using the disk method, we make it perpendicular. See, that is the only way to make it into a radius for our disk. So what that means is we now need to label it as x and dy because we are along the y. Remember, if we make the horizontal rectangle, it's dy with x. If we make a vertical, then it's going to be y and dx. So now we can take and make our circle here. And then as we've rotated it and then translate that rectangle through, it looks like this picture-wise. So here's our rotation. So as we move it through, you can see that is our circle as we move through it. The radius here now is an x equals because it's this direction. So it will be x equals with a dx. And then as we go from 0 to 8, it will give us the volume of all those little paper thin disks, and then we can add them up with our integral. So now that we've labeled it x equal, we know our radius is x in this case, which is solved. So if we solve this for x, we end up with the cube root of y. So every time you write x equals, you need to go back and make sure you solve the function for x, which will allow us to find out what our radius is in this case. So if we draw our circle, we now know our radius here is the cube root of y. So our area would be pi r squared, which is pi cube root of y squared, which would be pi y to the 2/3. So now that we have the area, we can do our little formula. So we're going to go from 0 to 8 of our pi y to the 2/3 with a thickness of dy. And so everything is about how this rectangle transfers through here. So you can see that we're going, as it moves up, that rectangle is going from 0 that we would plug in now all the way to 8. So we're plugging in y values to get all of our dimensions here. So we've got to go from 0 to 8 to find all of our radii. So the way I like to look at it is you have a dy here. You will always pick the numbers that are on the same axes as the dy. So that is our thickness. We're going to go from 0 to 8 with our radius with a dy. So now if we plug this in our calculator, it's going to give us an approximate answer. This one's not too bad to find by yourself, so we're going to do this by ourselves here. So this would become y to the 5/3, 3/5, and then pi, 8 and 0. So that's pi 3/5, 8 to the 5/3 minus pi 3/5, 0 to the 5/3. So I just put all that together because I already know the next part's just going to become 0. So we don't have to worry about it. And then so 8 to the 5/3 would become 2, and 2 to the 5th is 32. And so we would end up with 3, so 96 over 5 pi. And so if it's asking for an exact answer, sometimes the calculator won't give it to us. So you can see it gave us this. It will not convert it into a fraction. So 96/5 is 19.2, which is the same thing, but sometimes you do have to do it by hand. So if it's asking for approximate, go ahead and use the calculator. If it's asking for exact, you sometimes have to default to use your old method. Okay. So now it says use the disk method to find the volume of the solid formed by revolving this region bounded by this and the y-axis about the y-axis. So we already know how x cubed looks from 1 to 4. If you plug in 1, you're going to get 1. And if you plug in 4, we're going to get 64. So I can go 164 and put it here. But I'm also going to check it in the calculator to verify that that is the region that I'm rotating. Now, I just put it on the wrong side. We know we're rotating it with the y-axis. That's what it says. It's bounded by the y-axis, so I have to move to the y. So this will be my rotation. So verifying in the calculator, we have our x cubed, and now with your window, you put 0 to 4. And why am I using 0, not 1? Well, we're rotating about the y-axis with a disk, which means I'm going to have to go from here to here. So you don't want to put in 1. Which is fine, but you have to go back and change it. And then hit zoom fit again, and it's going to change it. So you really just want to plug these numbers in. We know it's 0, so it's going to go from 0. And then we know the ending point is 4. So 4 cubed is 64. So it's easier just to plug in 0, biggest x is 4, 0, biggest y is 64, and then hit graph to get the picture that we have here. And so you can see we're going from this to here, and that is the area that we're looking for. So if we draw our rectangle right here, and how do I know that I'm doing it as a horizontal? It's because we're rotating it about the y-axis, and we need to make sure that we make a disk. So that would make this x equals, and this is dy. You can already see that this is a perfect rectangle. As we move it through our picture, it's going to be the exact same rectangle all the way through. So we are going from 1 to 64. You can already start that. Put that in blue. And then dy. So again, to find these values, you're just plugging in the x values. So plugging in x, it will give you the y. Plugging in x gives you the y. So we're going to go from 1 to 64. And again, that was just by plugging them in. All right, so now we need to make this circle. And what is its radius? Our radius is x, which is, it's not solved. So we've got to go back over here and say y equals x cubed and solve for x. So again, it's the cube root of y. So all we've done is changed it to an interval that's given for x. Okay, so now our radius is the cube root of y. So our area is pi r squared, which is pi cube root of y again squared. So pi y to the 2/3. Plugging that in over here, we get pi y to the 2/3. And then again, take the pi out. And there you have it. So if you're given the interval for x, all you need to do is plug it in to find the interval for y. Okay, so this becomes again y to the 5/3 and then 3/5. We flip it, putting in the pi, 64, and 1. And so let's check our calculator to see if it gives us an exact answer. And it does. So we're going to get 3069 over 5 with a pi. So 3069 over 5 pi. All right, so that's how you rotate with disk about a y-axis. Again, it has to be the horizontal if you rotate about y and use disk, and it has to be vertical if you rotate it about x. Now we should probably also fill it in, so do make sure that you fill in, make your solid basically.